Have you ever heard the song Big Yellow Taxi? It's one of our favorites. It was originally written and recorded by Joni Mitchell back in the 70s, and there have been a lot of singers who have their own recordings of her song. It's a great song. The song has this verse in it that asks farmers to put away their DDT. You know when you're young and you don't understand a lyric in a song, so you kind of make up what that might mean in your head? Okay, well maybe that's just us. But we didn't really get that lyric until we got older, and now we do. And it's so much more powerful now. So, of course, it deals with science. DDT is a chemical pesticide, and it's called DDT because it stands for this. Yeah, so we're going to call it DDT. Its use really sparked in the 1940s as a powerful chemical pesticide, meaning it was used to kill insect pests. Often the types of insect pests that destroy crops, so it was popular in agriculture. DDT was very popular, but DDT soon came under some scrutiny. It became evident that this pesticide was having some negative environmental effects. In 1972, the EPA issued a cancellation order of DDT. And the EPA still works with other countries to control substances such as DDT and similar chemicals. DDT is used in other parts of the world, such as areas that are battling malaria and therefore looking for mosquito control options with indoor residual spraying. But it's definitely far more regulated and controlled in its use today. One thing that DDT really taught us is the effect goes far beyond the little insects that it may be targeting. Some high-level consumers, such as bald eagles, for example, really took a bad hit from DDT. For bald eagles, this affected reproductive abilities, including severe thinning of bald eagle eggshells. But why? After all, bald eagles do not typically eat the small insects that the DDT targeted. This takes us into our topic of biomagnification, and biomagnification doesn't just involve DDT. There are many chemicals and toxins that can be biomagnified. Mercury is another example that you might hear about. So when you think of anything being magnified, you think of it getting bigger, right? Well, biomagnification describes what happens when toxins become more and more concentrated in the living tissues of organisms as you go up in the food chain. But why does this happen? Well, take a look at these little bugs here. Imagine that perhaps these insects have been poisoned. Here are some still living poisoned insects. They're weakened, and some may make easy targets for predators. This poison is killing off a lot of the insects, but not all of them. Each of these insects will contain one triangle, which represents a concentration of that toxin. Now imagine these insects are eaten by secondary consumers such as lizards or rodents, and as those secondary consumers eat those insects, the toxin concentration level increases in the secondary consumers. Why? Well, recall in the energy pyramid, organisms only keep 10% of the energy, approximately, from the trophic level below. The remaining is lost as heat or undigested. That means that as you move up trophic levels, the animals will have to consume far more biomass from the level below to be able to compensate for this and survive. And everything it consumes from that trophic level below could have that toxin stored in its tissues, which now is an unwanted gift. It's adding up. Now, if a predatory bird begins to eat these secondary consumers, this concentration further increases. Remember, it only gets 10% of the energy from the trophic level below. And so, as a tertiary consumer, it must eat a significant amount of secondary consumer biomass to survive, increasing toxin concentration in the tissues. The problem with many toxins or chemicals is that if they are not controlled well, they can get into the air, the soil, the water. With DDT, it was able to get into the water supply. Primary consumers, such as this small fish, began to feed on those producers. And the concentration in body tissues of the poison in the primary consumers increased due to biomagnification. Secondary consumers, such as the larger fish, feed on those primary consumers. The concentration in body tissues of the poison in the secondary consumers increased due to biomagnification. Tertiary consumers, such as bald eagles, feed on the secondary consumers, and the concentration in the body tissues of the poison in the tertiary consumers increased due to biomagnification. So in summary, biomagnification is a major factor to consider for any pesticide or chemical toxin that humans may produce. We need people like you to come up with new solutions. If you take a look at the end of our virus video, you can learn about a virus that has been used as a pesticide because it attacks specific types of pest insects. Well, what if viruses were manipulated to attack specific pests to avoid the use of a toxin? But even then, could there be consequences for taking out specific types of pest insects? One last thing to mention, animals like bald eagles, they can face additional problems, such as habitat destruction, habitat loss, and poaching. There are ecologists who devote their lives to helping these organisms and raising awareness among people like you. Truly a career for the brave and bold. Well, that's it for the Amoeba Sisters, and we remind you to stay curious.